At what pressure should we run our tank cleaners? And is higher pressure more efficient, more effective? Now this is an interesting question that we get asked an awful lot at the spray nozzle people when sizing in new or upgrading tank cleaning systems. And there's some counterintuitive and somewhat surprising answers to this question. So let's have a look at each type of tank cleaner in sequence. For spray balls and other static non-moving tank cleaners, the general rule is you really don't want to go much above 3 bar in pressure, in fluid pressure, and not really anything below 1 bar. A sweet spot of around 2.5 bar is about right. But I wouldn't increase any pressure more than that. Now this may seem surprising and counterintuitive. Surely, you know, if we increase the fluid pressure, then we're going to get more impact and we're going to get a better clean. Well, actually, no, we're not. Now spray balls, and the reason for this is when you think about it, spray balls actually have very poor nozzles in them. Effectively they're a sphere with multiple holes drilled in them, and so those holes act as multiple nozzles. But they're very poor nozzles. There's not a lot to them. They're just a hole in a sheet of metal. So the jets that come out of these don't have very good integrity. So as we increase the pressure, we increase the velocity of these. They tend to break up and atomize quite easily because it's a poor quality jet coming out of it. So as we increase much beyond that sort of 3 bar pressure threshold, all we're really doing is atomizing the fluid more, and we're destroying any extra impact that might have been achieved by the increased pressure. So we're basically wasting energy. So there's no real point in spraying them much above sort of 3 bar. So for spinners, so spinning spray balls, these rotary ones, the situation actually quite similar. Anything much above the sort of 3 bar pressure range, they're going to start spinning faster and faster, and you're going to start flinging that water around really quick and atomizing it more. So again, you've got a sweet spot of around 2.5-3 bar, maybe a little bit more than that, where you can get the optimal cleaning out of them. And anything much above that, you're going to not get any extra impact out of them, and you're also going to increase the wear on these spinners, because as they spin faster, they start to wear more easily. So you're going to start to run into problems with wear as well. So you want to keep that pressure around about the 3 sort of bar mark, not much more than that. Now for rotary jet cleaners, the situation is different. These cleaners have specialist nozzles on them that are designed to keep their jets in laminar flow even at relatively high pressures, so that we have a coherent jet coming out of these jet cleaners that's designed to stay laminar, to not break apart and deliver its impact to the walls. That's the whole point of these tank cleaners. So they're going to give good stable jets up to pressures of, for most models, up to around about 10 bar. Now, increasing pressure from 2 to 6 to 10 bar will improve both the jet length and the impact, and it will also improve the overall efficiency of the tank cleaning head. And the reason for that is they rotate through their cleaning cycle quicker and quicker as we increase pressure, and the decrease in the time it takes to complete its cleaning cycle more than offsets the additional flow rate we'd get at the higher pressure. So what we find is the overall liquid used per cleaning cycle on any given tank cleaner actually comes down as we increase pressure, and the sweet spot's normally around about that 8 to 10 bar mark, where they're the most efficient. So they'll use less per cleaning cycle, and they'll have an improved cleaning action due to the improved mechanical action of the jets. Now for high pressure tank cleaning, and this is high pressure tank cleaning jets, which defines anything running above sort of 50 bar, and they often run a lot more than that. We have these high integrity nozzles that produce these needle-like laminar flow jets even at very high pressures. But because the pressure is so high and the resulting velocity of those jets is so high, this laminar flow can't be maintained for as long as in the lower pressure 10 bar sort of rotary jet cleaner styles. So we actually find that the effective jet lengths are reduced, and this is because they're typically very low flow rate, running at very high pressures and so very high speeds, and so much beyond a couple of meters from the tank cleaning nozzle, and we start to see that atomization effect come into play again. And so they're not really suitable for very large tanks where we require a jet length of 4, 5, 6, 7, 8 meters or whatever. You probably wouldn't use one of these high pressure nozzles in that situation, because even though they've got the higher pressure, the jet lengths just aren't effective at those ranges due to that atomization effect. Now you can use them on bigger tanks with multiple, if you can facilitate multiple stage cleans, so you effectively move the high pressure cleaner to different parts of the tank so it can clean each bit within that relatively short range of its cleaning jet. So that can be done as well, and that can be a very efficient way of tank cleaning. But unless you can do that, you wouldn't use them for you wouldn't use them for big tanks. So to recap, the general rules we have are, for spray balls and other static nozzles, you want to keep the pressure around 2 to 3 bar for optimum results. Any more than that is normally just a waste. For spinners, the same rules apply. So around about that 3 bar, anything more than about 3 bar is going to be, pressure is going to be a bit of a waste. For rotary jet cleaners, we improve efficiency as we move up the pressure, and the sweet spot on those is normally about sort of 8 to 10 bar. You want to be trying to run them at those pressures for optimal results. And then for high pressure jet cleaners, run them at the manufacturer's recommended pressures, but bear in mind that because these jets are moving so fast, they do tend to atomize at a relatively short distance from the jet, so you wouldn't want to be using them whether you require a jet length of more than sort of 2-3 meters or so. So I hope that guide's helpful, and that gives you some guidance on what are the optimal pressures for the various different tank cleaners.